Hi, everyone, and welcome back to Spotlight with Scientists in School. I'm your host, Betty Bacopoulos, and today I am thrilled to be joined by Dr. Rowan Thomson. She is a professor in medical physics at Carleton University, and her research in radiation therapy was awarded the Polanyi Prize for Outstanding Achievement. And today we chat about how we can affect change and dismantle structural barriers that women face in physics. It's a conversation you don't want to miss. She joins us from Ottawa. Let's head on over and meet Dr. Thomson. Hi, everyone. Welcome to Spotlight with Scientists in School. I'm so excited today to be joined by Dr. Rowan Thomson. Welcome to the show.
Thanks a lot. I'm happy to be here.
I'm really excited. I have been looking forward to this conversation since the day that you agreed to be a part of it. So let's start right at the beginning. You are a physicist at Carleton University, but did you always love physics as a child?
I didn't actually. So when I was a child, I did all sorts of stuff. I did Lego. I loved to do art. I played the flute, so I started playing at age 9 and played right the way through high school. I loved to read. So I love doing all sorts of stuff, playing outside, skiing, biking. I loved math and science and sort of always saw myself going into science, but I don't think I really knew what physics was until later in high school and maybe even university.
Now, did you have role models along the way, though, that supported your love of science or physics?
That's right. So my family really valued learning. So I think that it was a good environment for enjoying learning. And there were some teachers at school who were really supportive. So especially in high school, I remember a chemistry teacher who was really enthusiastic about talking about the atomic model. So it's actually Bohr's model of the atom. And we needed to learn about this for understanding elements and how they might bind together. And actually, this teacher introduced a bunch of ideas of quantum mechanics, which is modern physics, in this chemistry course. But this was kind of next to my physics course, which I actually found really boring at high school. So I actually started university in biology and chemistry, biochemistry, because that's what had interested me in high school, whereas physics I thought was super boring.
That is a surprising answer. I thought you were going to say you love physics and you did all of that.
No, so in high school, I what I remember is stuff like applying equations to, how fast is a car accelerating or a car going. Or we did a project, I remember, where we built bridges out of popsicle sticks and look at how much math it took to destroy them. Yeah. And those are interesting things. Yes. I don't mean to diss them, but it sort of didn't spark my curiosity. Right. And I think this is a great example of maybe how sometimes there's a disconnect between what interests the learner in certain subjects and how it's being taught. And if we change the way we teach, then maybe we can make it more inclusive and more interesting to diverse learners.
Right. And not everybody learns the same way, right? Some people, you got the auditory, the visual, you have some of them that love to take things apart, right? So there's lots of different learning styles. That's right. Yeah. Interesting. Yeah. Now, we don't need to spend too much time to argue the point because I'm sure we're on the same page. Girls are just as good at math and science. So we don't need to debunk those myths. But something happens at around the age 16, right? You've heard of the leaky pipeline, where girls start to, drop off, right? The numbers start to go down. As an adolescent or as a young woman in physics, did that ever deter you? Did you ever think of choosing another career option because there weren't as many women?
So I always had this sense of there weren't as many women in science, but that was changing, and it was changing right when I was there. And that's what I believed at the time. So it was just like, I'm part of this wave. It's all going to change. It's going to get better. So I already said I started university in biochemistry, and I don't remember noticing a difference in men and women in those classes. But then when I realized in that first year physics course, I really love physics, and I'm not enjoying chemistry as much, and I switched to actually a double honors math and physics, then I started to see this disparity in representation, but I really hadn't been aware of it before then. So I think part of it's related to role models and what people see in the wider world and what's in the popular culture in terms of who are physicists.
Role models. It's interesting you bring that up because young girls talk about role models all the time. But in doing research before talking to you, that word came up so much with adult women doing their PhDs in physics.
Yes.
That word kept coming up, how much even women needed role models in the programs. I actually was very surprised when I researched you. You said in one article that in 2001, you were at a conference at the National Research Council of Canada, and you were in a room full of men. At the Perimeter Institute, you were the only female in scientific meetings. You only had 2 female professors at university, and in your PhD defense, you were the only female. Like, what made you persevere? That sounds daunting, maybe. I don't know. What made you persevere?
Well, it's really weird, I have to tell you, going from everyday Canadian life where I am not a visible minority, and then suddenly being in this environment where, it's like, what happened? Why is it like this?
Right.
But again, I always had this naive expectation. It's going to keep changing. The next step of the way, it's going to be different. What's it like? Yeah, it's really strange. And I think what it ultimately is, and it's taken me many years to realize this actually, and in seeing my own students come up against the same barriers, but it's again, this lack of role models, which leads to a sense of, do I belong here? Is this the place where I'm going to have a career and a life with all the different things I want in my life that's fulfilling? Because when you look around, you don't see people like you. So I think that consciously, and probably there's a lot of unconscious stuff that happens, you go, do I belong? Is this my place? Should I keep going in this direction? And for me, I remember when I was a PhD student at the Perimeter Institute for Theoretical Physics and at the University of Waterloo, I started to feel, if I keep going in theoretical physics, which is what I was doing at that time, is my life going to turn out the way I want it to? And I ultimately came to the point where I felt like it's not going to, if I keep going in this theoretical physics direction. And I changed. So I now work in a different area called medical physics. And that's a bit of a story how I got there. But I think it's this sense of belonging is really important. And I persisted because I love what I do. I love doing physics. I love doing math. I love using it, to describe the universe, and now to work on better treatments for cancer. So physics can do all these things. It's amazing. That's why I persisted. But there are barriers that are visible or invisible all the way along. And as a trainee, I wasn't necessarily aware of them. People weren't talking about them. In fact, when I was a grad student, no one talked about the fact that I was the only woman there.
Right.
So it was really, really strange in a way.
So you had to do a lot of soul searching, a lot of asking yourself, is this the path I want to take, right?
That's right. Yeah.
Now,
and then started looking around for other things.
Right, of course. And now you are in a position where you can affect change, actually, because you are the Assistant Dean of Equity, Diversity, and Inclusion at Carleton. Tell me about that and how we can affect change.
Right. So this is a position that started just under a year ago. And it's all had to happen. It happened just after the pandemic started. So it's all happened in this interesting and strange environment. But yeah, I finally, I guess, got to a point where I said, hey, there are things we can do to affect change. We can do them at the university. And I started talking about it, and amazingly, people listened. And so the dean approached me and said, would you like to take on this new position? And, what can you do? What are your ideas? Go for it. So I think the first thing we need to do is build awareness. So people in different areas of science and engineering look around, and they know there's this lack of diversity, but they don't really know why. And there's a lot of research that tells us why. So it's really well documented now. There's data that demonstrates that what people experience is happening. So so it's been likened to a glass obstacle course. So this experience of encountering unexpected barriers at each career stage, at each study stage, which is certainly what I've experienced. You could also liken it to molehills. So we encounter different molehills on our path. Each one is not insurmountable, but the cumulative effect is really significant. So many molehills make a mountain, and this is what pushed people out of the field. So I think we build awareness, which we've started doing at the university, then we can engage people in affecting change, because they say, hey, this is happening every day around me. What can I do to change it? So we've started an event series, which we call ACE EDI, where ACE stands for Awareness, Collaboration, and Engagement. And these are events where we so far have virtually brought together people, but like we bring in an invited speaker, They give a talk, and then there's questions and discussion, or maybe there's a panel, and it's covering all sorts of topics. So how can we teach such that it's more inclusive? What can we do with our research groups? What can we do in the broader community? So it's an opportunity to build awareness and spark engagement. Another thing, so we are working on lots of things, making hiring more inclusive, making sure our research teams have everything in place so that our students can succeed to reach their potential. But I think a great opportunity is in teaching. So at the university, we teach students who then can go out and become agents of change. So if we help them understand how different groups have been historically marginalized and not fully included, women, but also others, so Black, Indigenous, persons of colors, people with disabilities, LGBTQ2+, then if we educate them about what's happened, but then also give them tools to address these systemic issues, then they can go out in the world and affect change too. So I see a real opportunity through teaching to affect change.
That's great. Having a conversation is the first step, but you got to give them tools, right? We got to know what to do with it. Yeah, that's fantastic. So congrats on getting that off the ground. Yeah, actually, a lot of exciting projects happened during the pandemic. I don't know what it is. The virtual world, somehow everybody started thinking outside the box. So there's been some good stuff for sure. I'm going to switch gears just a little bit and talk about the Nobel Prize with Professor Donna Strickland at the University of Waterloo, who won a Nobel Prize for her work in lasers. Unfortunately, her win, what I found very sad was, here is this woman that wins this fabulous prize, and a lot of the conversation is not about the work she did. A lot of the conversation was that Professor Donna Strickland is a female. It'll be nice when that conversation can stop and we just focus on the work, right?
Certainly will be.
Right, that'll be great. First of all, why did it take so long for a woman to win this prize? I think at the time, was it 55 years since the win before? There must have been women worthy within that time frame.
I think there were. And I think there are lots of there are lots of reasons, and there are actually research papers that are written about this. Okay. Why are women not being recognized as much? So some people will point to there weren't as many women in senior researcher positions, and so kind of the pool of candidates is not there. But research shows that actually women are underrepresented, even when you consider that the pool of candidates is smaller. So then there's the question of, or the possibility of bias and unconscious or implicit bias, where, so bias is a normal thing we all have. It's essentially shortcuts in our brain that help us deal with the everyday world. So meaning we categorize people or interactions in certain ways. The problem is when it means that we disfavor the contributions of persons of certain identities relative to others. And so there are suggestions that unconscious bias is part of why women are less well represented. And it may not be unconscious, it can be also conscious as well. I think that's part of it. So there are fewer nominations for women, as well as women may well experience more of these barriers throughout their career, which hinder them in their realization of their full potential.
And the other thing that was surprising were some of the comments that were made by male physicists once Donna received the prize. And, if I did a cut and paste of some of those comments and sent them to my kids, they wouldn't have thought that they're being said in 2018 at the time, right? They seem far out comments. And I'm thinking, not only are girls hearing this, but boys are hearing this as well, right? So how do we debunk some of these myths? How do we stop that conversation from happening?
Well, we need to show that it's really harmful, that this is hindering people from achieving their potential. And we need to educate people that these comments are damaging to the next generation, because they may then choose different careers. Right. So if I can tell the next generation of students and physicists something, I would say, yes, bad things have happened, or things have happened in ways that they shouldn't happen, but we are affecting change. Right. So it won't keep going like this. We are making things better, and you can be part of the change, and you should be part of this conversation, and all of us will make change together.
I was also surprised to find out that there wasn't a Wikipedia page of Professor Strickland until the day she won the Nobel Prize, right? So that's shocking. It is
Yes.
very surprising. Let's turn it over and talk a little bit about what you're doing. You've won the Polanyi Award, the NSERC Award for Outstanding Research. You are a professor at Carleton Medical Physics and Radiation Therapy. Tell me a little bit about your research and why it's important to you.
So I do research modeling the interactions of radiation with matter. So I develop sort of theoretical techniques and apply them computationally, so using lots of computers, to understand how radiation interacts with matter. And often I'm thinking about radiation treatments for cancer. Yeah. So lots of people have probably heard about people undergoing radiation treatments. About 25% of Canadians are likely to undergo a radiation treatment in their life for cancer. Wow. Right now. Yes, it's a big fraction of people.
Yeah.
Yes. And physicists are very engaged in the process. So here in Ottawa, where I live, the medical physics group at the Cancer Center has about 20 PhD physicists. So they play a really important role in delivering of radiation therapy treatments. So I do research related to these treatments. How can we plan them so that they work better? How can we make sure that the tumor receives the radiation dose that it needs to kill cancer cells, while sparing surrounding healthy tissues, while preventing secondary cancers from happening? So I work on things related to current day treatments, but then I'm also working on stuff that's a lot further in the future. So how can we model targeted radiation therapy treatments that might involve sending nanoparticles into cells and targeting the radiation directly to the cells so that we can kill the cancer more effectively, and cure people? So personally, this research brings together both my love of math and physics, because it's needed to model these treatments, but also a very tangible result in that, oh my goodness, I'm working with radiation oncologists and physicists who work at hospitals and directly affecting patient treatments, which means maybe someone's grandpa doesn't die of this cancer, or someone's parent. And so there's a real tangible benefit. And another part of the research in my work that I find very meaningful is teaching and training students. So my students then go out in the world and find all sorts of wonderful things to do and affect their own change. So I find that incredibly rewarding as well.
Absolutely. I don't think there's one person that doesn't know someone who has undergone radiation therapy, right? So yeah, that's a big number, 25%. Now, how do you juggle it all? Like, how do you juggle everything? Mom, life, you're at home probably.
Yes. So it's crazy. There are lots of balls in the air. But I focus on when I'm working as efficiently and effectively as I can, figuring out what tasks need a lot of time and giving them that time, and what tasks can be done more quickly, and having confidence in myself to be able to do them quickly. Also really important though is recognizing when I need a break and when I need to take time for myself.
Right.
And I think a big part of it too is perspective. So knowing that I will only have a young family at one time, and so going and playing at the park is really important, and going on bike rides and all those other things that are wonderful.
So balance.
So I would say, time management and perspective, putting everything in its place. Yeah. So I think when we're able to bring all aspects of ourselves to our job and be the fullest kind of people we can be, then both our job and our personal life flourish. This idea of a scientist who works 80 hours a week at the expense of all other things in their life, that's not a good picture to be projecting.
Right. You got to have balance, right? You can't miss, like you said, those moments. Your kids will only be young. That's right. A fraction of our lifetime. If you met yourself as a younger student or a young girl today saying, oh, I'm just wondering if I should, do physics or not, would you tell them to stick it out, and why?
I would. I would say you absolutely have to find what you love. You're going to spend a lot of your life working. And if you can find something that you love, it will get you through all those tough patches, all the challenges. And so then you will flourish more as a human being, which I think is what we need in society, is people being able to bring their whole selves to what they do. So I would say find what you love and then persevere in doing it, but that love will carry you through the challenges along the way that you may encounter, which we will all encounter in our careers or our work and studies.
That's really great advice. I say the same thing to my girls. Do what you love and you will be happy. It won't feel like work every single day, right?
That's right.
Yeah, that's what we all need. So it's great that we had this opportunity to have this conversation. Thank you so much for taking the time. And good luck with all your research and your work over at Carleton University and with your new role as Assistant Dean.
Thank you very much. It's been my pleasure.
Yeah, thank you. Take care.
Thanks.